this question, they've given us the 3 points A, B, and C with the following coordinates. A has the coordinates 0, 7, B is 8, 3, and C is, in terms of this constant K, is 3K, K. Now we have to find the value of this constant when this point C lies on the line that goes through A and B, or when C lies on the perpendicular bisector of AB. So we're going to get two different values of K, one for each of these parts, for each of these scenarios. Now for the first part, when we have to find the value when C lies on the line that passes through A and B, that means that we have to first find the equation of the line. So then y is equal to mx plus c. That's the general form of the equation. And we know that the slope over here is simply m is equal to y2 minus y1 over x2 minus x1. And now let's take each of these. Let's take A as the point x1 comma y1 and B as x2 comma y2. And when we do that, we realize that, well, y2 minus y1, which is the slope, is simply m is equal to 3, which is y2 minus y1, which is 7, over x2, which is 8, minus 0. So our slope comes out to minus 4 over 8. So our slope is equal to minus 1/2. So that over here is our slope. So now we have the equation y is equal to minus 1/2 x plus c. Now if we plug in either of these points, we can calculate the value of c, because both of these points will satisfy this linear equation. Now we don't really need to do that here, because they've already told us that when x is equal to 0, y is equal to 7. So this is actually the value of the y-intercept. In other words, c is equal to 7. So if I plug that in, if I plug in the point A, I get 7 is equal to 0, which is minus 1/2 times 0 plus c. And I get c is equal to 7. So now I have the value of c. So my linear equation is y is equal to minus 1/2 x plus c. Y is equal to minus 1/2 x plus 7. Now this is my linear equation. Now if the point C lies on this line, that means that when x is equal to 3k, y must be equal to k. So the point C should satisfy this linear equation. So when y is 3k, x is k. So when x is 3k, y is k. So when y is equal to k, x is equal to 3k. So minus 1/2 times 3k plus 7. So that comes out to k is equal to minus 3 over 2k plus 7. And if I add 3 over 2k on both sides, I get 5 over 2k is equal to 7. And I multiply by 2 over 5 on both sides. To simplify, I simply get k is equal to 14 over 5. So that's the answer for part 1. K is equal to 14 over 5. Now for the next point, the next part they've told us, the C lies on the perpendicular bisector of AB. So we know that C lies on a line that's perpendicular to AB, and it passes through the midpoint of AB. In other words, it divides this line segment AB in half. So first what we're going to do is we're going to find the midpoint of the line. Now the midpoint of the line segment, or the line AB, is equal to, if we know this, x1 plus x2 over 2, comma y1 plus y2 over 2. So that means we're going to take the same values of x1 and y1 for A and x2 and y2 for B. And when we plug in those values, we get 0 plus 8 over 2, comma 3 plus 7 over 2. So we get 8 over 2, comma 10 over 2. So the midpoint is equal to 4, comma 5. So that's the value of our midpoint over here. And that's the value of our midpoint. Now, once we have our midpoint, we know that the perpendicular line, the perpendicular bisector passes through this point, but we also need to figure out the slope of this line. Now we know that the slope of a line that's perpendicular to a given line is simply the slope of the perpendicular line is the negative reciprocal of the slope. In other words, we already know the slope of the line AB. That's minus 1/2. So the slope of the perpendicular line will be minus 1 divided by minus 1 over 2. So that means that the slope of the perpendicular line is equal to minus 1 times minus 2. So that comes out to positive 2. So that's the slope of this. That's the slope of this given line. So now we have a known point and we have the slope of this perpendicular line. We have a known point and we have the slope of this perpendicular line. So that means that if I plug in this, so now I know that the linear equation for this perpendicular bisector is equal to y is equal to mx plus c. And I know that y is equal to 2x plus c. Now, if I know that the point capital M over here, which was the midpoint for AB, lies on this line, then this point or these coordinates should satisfy this linear equation. So if I plug in these values over here, so if I plug in the values of capital M over here, that means that when x is equal to 4, y is equal to 5. So 5 is equal to 2 times 4 plus c. So 5 is equal to 8 plus c, and c is equal to minus 3. So my linear equation then comes out to y is equal to 2x minus 3. When y is equal to 2x minus 3, now we have the equation of this perpendicular bisector. It has slope positive 2 and a y-intercept of minus 3. Now, once I have the equation, the point C lies on this perpendicular bisector. In other words, the coordinates of C should satisfy this linear equation. So if I plug in C into this linear equation, I will get when x is equal to 3k, y is equal to k. So k is equal to 2 times 3k minus 3. So then k is equal to 6k minus 3. So that means that minus 5k is equal to minus 3. So that implies that k is equal to 3 over 5. So then the value of the constant k for part 2 is equal to 3 over 5. So that's our answer.